guys started working on absolute value functions and realizing, and these are absolute value linear functions because they all look like lines that form as V's and all that. But what we're going to do before we enhance all of the absolute value functions is take a step back and take a look at piecewise functions. And a piecewise function, what is a piecewise function, you ask? Well, it's a function that graphs parts of a function by restricting its domain. So if you look at the first thing that I have on the screen here, because I can see you guys are eyeballing the screen, this is the line y equals x, right? So this is the line y equals x. And given that you have this line y equals x, not y equals x, y equals 1/2 x, forgive me, we know it passes through the origin because the y-intercept is 0. But I'm only graphing the line from -2 to +8. And if you want to graph piecewise functions in Desmos, you have to use that brace right there that's on your keyboard that'll actually help you restrict the domain so that way you can only graph parts of a function. So we're going to be getting into what that looks like. So if you look at something like this, so it says, and they like to call it compound function, I like to call it a piecewise function. So when you're looking at this, a piecewise function, this consists of 3 different functions, okay? And these 3 different functions, it's basically saying, I want you to graph the line 2x plus 4 when x is greater than or equal to 9. I want you to graph the parabola x squared minus 4 where x is between -7 and +9. And I want you to graph the function f of x equals 5 when x is less than -7. So when we're trying to figure out values of these functions, so in other words, I'm going to use the line 2x plus 4. And if I were to just do a quick graph of this, just because I can, all right, because we're going to get into this later anyway. 2x plus 4 when x is, let's say we're out here at 9, okay? So 2x plus 4, and you see how it's equal to 9? So 2 times 9 is 18 plus 4 is 22. So it's going to be somewhere up here. We're going to say it starts here, where this is the number 22. And then it's going to be a line that goes off into the sunset. You're going to go up 2 and to the right 1. So if I go up 2 and to the right 1, I'm going to be at the point 10, 24. Drink that one and then tell me how you know that. So that takes care of this part. Then the next thing is going to be x squared minus 4. Now x squared minus 4 looks like a parabola. That's going to be, you know, something like along the lines of this, and then it's just going to go off into the sunset. If I plug in 9, even, you know, if I plug in 9, I get 81 minus 4, which is some kooky number. So it's going to, actually, you know what? This is annoying. This is annoying. So what I'm going to do, I need more space than this. I'm out of my mind right now. Actually, you know what we're going to do is I'm going to show you what this looks like on Desmos. The point of this first problem is not to actually graph it, but you know me, I can't help myself. So just give me a second here. So what I'm going to do is I'm going to write these down real quick. But as we're doing it, it's nice to see that as I'm writing these functions down, f of x is equal to 2x plus 4, where x is greater than or equal to 9. Notice, oh, this is what I want you to notice. You notice that I can't have an equal sign in both places. I can have an equal sign here, or I have to have the equal sign there, because otherwise it wouldn't be a function, because if you pass the vertical line test, you can't have a point up here and a point down there. So noticing that these are in fact functions. So if you notice here again, -7 is included in this function here, but less than 5 it is not. So so that's one thing that I want you to notice, and we will certainly talk about and discuss. So this over here, hold on, x squared minus 4, -7 less than or equal to x less than, whoops, just less than 9. And then 5 when x is less than -7. We're going to graph that later because I want to address this first part over here, that if you want to find out what f of 10 is for this particular piecewise function, you have to decide which of the 3 functions to plug the 10 into. And based on the restrictions over here, based on your restrictions, your domain restrictions, it's going to help you dictate which function you're going to plug those corresponding values in for. So for example, if you look at f of 10, well, 10 is bigger than 9 because we're looking, this function here applies for anything that's 9 or bigger. So 9, 10, 11, 12, off into infinity. So if I want to find out what f of 10 is, I'm going to plug it into the top function 2x plus 4, right? So this one is going to be equal to, hold on here. So this one here is going to be equal to 2, whoops, come on, Shar, 2 times 10 plus 4, so that's going to give me 24, okay? If I want to find f of 9 goes with the top function because it's equal to 9. So therefore, this is going to be 2 times 9 plus 4, so that's 18 and 4 is 22. Now, the important thing here to remember is, again, I can't plug 9 into this function because it's everything leading up to 9. So I can put in 8.99999, we'll go into this function, 8.9999999. I just can't plug in 9 because 9 doesn't get included, okay? If I want to do f of 6, so the important thing is that f of 6 is going to be somewhere between -7 and +9. So that means it's going to go into this function. So this is going to be 6 squared minus 4, so 36 minus 4 is 32. If I want to find f of -5, f of -5 still falls in this domain right over here. So I'm going to do -5 squared minus 4, so 25 minus 4 is 21. And then f of -15, well, f of -15 is less than -7. And if you were to graph f of x is equal to -5, what does f of x equal? I'm sorry, +5, sorry. F of x equals 5 looks like what? That's right, it looks like a horizontal line. So if I were to graph this, it would be the line f of x equals 5. So in other words, anything less than -7, okay? So anything less than -7 corresponds to every y value, no matter what you plug in for x. If you're less than -7, the y value is always going to be 5. So this is, in fact, going to be equal to 5. And then if I want to find f of -7, noticing that this doesn't have the equal sign, this one does, it's going to get plugged into this function. So this is going to be equal to -7 squared minus 4. So 49 minus 4 is 45. And that's how we kind of go about addressing those issues, okay? So now, down here, we want to actually graph the piecewise function. We're going to go back up here. We'll graph this piecewise function on Desmos when the time comes. But anyway, in the meantime, I want to take a look at this guy right over here. So I have 1/3 x plus 2. So I want this function, this line, when x is less than 3. I want to graph this line when x is greater than or equal to 3. So one of the things that I like to do is I use the domain restrictions right here to help me find some points on a line. So we're doing less than 3. So we're starting from 3 and then moving off into the sunset. So if I were to plug 3 into this top function, that's going to be like what my boundary point is. So if I plug in 3, 1/3 of 3 is 1 plus 2 is 3. So over here at 3, 1, 2, 3, I'm going to put an open circle, and I'm going to call that 3, 3. Now, my slope is 1/3, right? My slope is 1/3. So I can, I'm not going to go up and right because I'm going less than 3. So I'm going to go down 1 and to the left 1, 2, 3. And noticing, wow, look at that. I actually hit the y-intercept down here. So down 1 and to the left 1, 2, 3. So this is what the top half of my piecewise function looks like. Now, if you look at this one over here, if I plug -2, I'm sorry, not -2. If I plug 3 into this function, that means that that is part of it. So like if I do this, I get -2 times 3 plus 6, which is equal to 0. So that means the point 3, 0 is a closed circle. Because remember, we can't have both of these filled in, otherwise it's not a function and it won't pass the vertical line test. So it's doing this, right? So, and then the slope is -2. So it's going to be, now remember, we could go up and left, or we could go down and down to the right. So down 1 to the right 1, down 2 to the right 1, and so forth, down and to the right 1. I'm going off the page, but I'm going to have something that looks like this. Now, you should find interesting, again, is that this is considered to be a piecewise function. It's a very pretty looking function. I like it a lot. And it kind of lets you know that, again, you can't be 2 places at once. Okay, you just can't. So what I'm going to do right now is we are going to run over to Desmos, because I love my Desmos. There you guys are. Say hi. This is for tomorrow, noticing I didn't publish it yet, but I will. So when we go into Desmos, I just want to show you that you can always graph piecewise functions, which is pretty fabulous. Let me see. I want to go into workspace here real quick, and I want to hide that so it's not in the way. Here we go. So we're going to do f of x. You have to do this in 3 separate things, but when you guys write it, it's 1. So f of x is going to be equal to, 2x plus 4. But again, you're going to go to those brackets, which are look near your return key, and look up and to the left a little bit, and you'll see it there. And you're going to do X, and then go down to your keyboard here, and you'll see that there's that greater than or equal to 9. Now, if you look at that, we can't see it here right now, and the reason why we can't see it is because we have to zoom out a little bit to see what's going on right now. So if I zoom out, you can actually see this a little bit better, okay? And we're going to adjust our window as we go along, and this is good practice for you guys too. So then the next one is going to be equal to x squared minus 4. Whoops, really? X squared minus 4. All right, and we can actually see part of that, but I only want, again, -7, go back to that keyboard, is less than or equal to x, which is less than 9, because remember, you can't be 2 places at once. And you can see it's actually breaking it right off like there. And then this is equal to 5. Whoops, f of x is equal to 5. And that is when x is less than 7. And close that baby out. Whoops, less than -7, not 7. Okay, -7. So we can see something like this, and what I'm going to do is I'm going to change my window because this bothers me. I hate these graphs. And by the way, you guys can do a better job with your windows when you're graphing things, so I'll be expecting you to do the same thing, okay? So we're going to change this to like where all the action's happening. I'm going to go -10. Whoops, I didn't mean to do that. Uh-oh. 101, right? Oh, I mean to make it negative. My book is butchering it. Okay. Actually, I meant to change the x-axis, not the y-axis. So we're going to go from let's go -20. No, let's go -50. See how I'm just adjusting so I can get a pretty looking graph here? And then I kind of like what I'm looking at here. Let's make this -100 just for fun. Okay. So now as we look at this, look at this. This is a really cool looking graph. Now, if you notice here, in here, this is where the function is defined at 9, because this is 9 right here. So the function is defined at 9 on the line, and the function is defined on the parabola at -7. So in other words, if I were to just look at the green line, and I were to say that x is less than 7, it would almost look like right here would be the depiction of a hole right there in that graph, okay? So, and I will talk more about that as we go back into workspace. So like right over here, do you see how on this one here where I had x was less than 3? That means that the function for this particular line is not defined in 3. That means f of 3 doesn't exist on this line, but f of 3 does exist on that line. So it's the same idea with the parabola and the lines and so forth, okay? So now for this one over here, if you want to hit pause and do this one on your own and then compare your answers with me, you know, I would love that. And so I, on the other hand, I'm just going to get like started in here. And one of the cool things that I could do is I can see that there is a restriction here from -5 to +1. So what I like to do is I like to plug in -5 and +1 to find out what my 2 endpoints are for this particular line segment. So, because it's going to be a line segment because my domain has been restricted. So what I'm going to do here is if I do -2 times -5 minus 4, and then I'm going to go -2 times -1 minus 4, this one is going to give me, what is that, -10? That's -14, right? So that's -14, and this is -3, so this is -7. So that means I have the ordered pair -5, -14, and I have the ordered pair -1, -7. So those are my ordered pairs. Now, if you notice looking over here, you know, it doesn't look like there's enough room on the grid. But there could be and should be enough room on the grid if you scale your y-axis as you need to. So before I do that, I'm going to go over here just to see how big or how wide things go, so that way I can scale my y-axis accordingly. So if I go to the second piecewise function, I'm going to have -1 plus 2, and I'm going to have 3 plus 2. So this is going to be 1, and this is going to be 5. So my ordered pairs are -1, 1. And the other ordered pair is going to be 3, 5. If I go to my third one, no matter what, it's going to be 2. So f of x equals 2. I hope you all realize is a horizontal line. So that means it's going to be 3, 2, and then 6, 2 are going to be those points. So now I'm noticing that my highest number is 14. So if I go 2, 4, 6, 8, 10, 12, it's still not enough. So the way that we could do this is A, you could do it on graph paper yourselves, or B, we could, you know, expand this. I'm going to expand this just a little bit. So I'm going to expand mine down a little bit because I am going to go by 2's on my y-axis. Why? Because I can. All right, so it's going to be something like that. So here we go. So I know that, bump, bump, bump. All right, so we're going to go 2, -2, -4. So we all get the picture. -6, -8, -10, -12. So -14. And then 1, 2, 3, 4, 5. So we're going to call this point. I'm going to change the color so it's better visible. So this is -5, comma, -14. And you'll notice that I filled this in because this is equal to. But then when I go to the point -1, -7, so -1, so this is 6, so this is, hold on, this is 6, and then negative, so it's going to be somewhere here. I'm going to go with an open circle over here at -1, comma, -7. And the reason why I have to do that is because it doesn't include -1 on this particular piece of the piecewise function. So it's going to look like that. And then I'm going to plot -1, comma, 1. So -1, 1 is going to be right, whoops, wait a minute. This is going to be, hold on a second here. Mama schwa, because I'm going to make my x's go up by 1, like -1, -2. So I kind of dropped the ball here. So let me go back and tweak. This is why this is a good thing. Okay. So buttons. So this is -1, so it's actually right there. Okay. All right, so now -1, comma, 1 is going to be right here, but it's going to be a closed circle because it includes that, as does the 3. So 3, 5, so 1, 2, 3, and then 2, 4, and 5 is right here, is going to have a closed circle. So it's going to look like that, okay? And then finally, 3, comma, 2 is going to be an open circle. So 1, 2, 3, comma, 2 is going to have an open circle, and 4, 5, 6 is going to be here, and that is closed, as you can see, and it's going to look like that. As time goes on, we're going to start attacking the domains and ranges. And, you know, for this one over here, if I asked you guys what's your domain and what's your range, I challenge you to hit pause right now and figure out what the domain and range would be for both of these. So I challenge you right now, hit pause and then get back to me. And I just realized something. Too. Yeah, I know. I graphed this wrong right here because, again, this is scaled by 2. I should have labeled my axes here. So this is a 4 here. So 2 would be here. And that's going to be, there we go. Now I feel happy. So it's going to look like this. Okay. All right. So I know that this point right up here is 3, comma, 5. And I know that that point down there is that one there. Just wanted to warn you that the range is very challenging, but let's nail the domain down. So I'll see you guys in a moment. For those of you who did it, your domain is actually going from -5 to +6. And noticing I'm using the brackets because it includes -5 and +6 because you're starting at -5 and you're stretching all the way over here to 6. Your range is beastly, but it's fabulous, okay? So your range is almost broken. Remember, your range is your y value. So you notice that there's all this space in between, so we're almost going to look at this from a vertical perspective as we go up. So if I look from here to here, I know that my y values are ranging from -14 to 7, -7 non-inclusive. So it's -14 to 7 non-inclusive, union, which means or. If I look over here, my y values are going from, this is 1, right, all the way up to 5. So 1 and up to 5 inclusive. Isn't that interesting that there's that like cool funky jump there? So yeah, like one of the things I'm going to have you guys do is I'm going to ask you to find the domain and range. Now before I send you off, I do want to do one more thing. Is let's say that, let's put 2 here. We'll put 4 here. We'll do 1, 2, 3. Okay. So let's say that we have something. I just want to show you that if I say to you guys, let's write the piecewise function. Okay. So let's say that we're going to go from here to here, where this is 1, comma 2, and we're going up to 3, comma 4. That's one of them. And we're going to do it like this. And then down here, we'll make this one open circle, 1 comma negative 2, and then let's just go like that, okay? And if I asked you guys to write the piecewise function for this, you guys have to find the equations of both lines. And if you notice, the change in your domain restriction is along your x values here. So to find the equation of this line, you have to do your y equals mx plus b, so you got to find your slope and all that other jazz. So if I do y equals mx plus b, we're going up 2 and to the right 2. Look at me how generous I am. So we're going up 2 and to the right 2. The slope of the line is 1. So that means then we can do, my slope is 1 times x minus 1 plus 2. For those of you who are, this is point slope form, but for those of you who are obsessed with y equals mx plus b, take your 1 comma 2 and you'll do 2 is equal to 1 times 1 plus b. So then b is going to be equal to 1. So the equation of this line is y is equal to x plus 1. The equation of this line is y is equal to, yep, negative 2. So we do this, we make this pretty little bracket, and now we know we want this line right here, x plus 1. We put over here x plus 1, and that's when x is greater than or equal to 1. And then we want f of x to equal this horizontal line of negative 2 when x is less than 1. And that's what that open circle means, is that we're not including that 1. And remember, they can never be filled in at the same time. So this is a really nice intro to piecewise functions, and it's going to segue into how we can write absolute value functions as piecewise functions, because that's coming down the pike this week. So I hope you all found this helpful, and I look forward to seeing the work that you do that I'm going to give to you on this.